This video shows how to determine the ASTM grain size number for a metal specimen. Generally, the strength of metal increases as the grain size decreases. Other properties, such as ductility, change with grain size as well. To begin, a metal specimen is polished and etched to expose the grain structure.
Here we have a microscopic photo of a 1045 steel sample. Now, what can we do with this photo? 1. Determine the magnification. 2. Find the grain size number. 3. Solve for the average grain size diameter. Let's start with number 1. Determine the magnification.
In order to begin, we must find the print size dimensions of the photo. We can select either the width or the height. Let's use the width of 165 millimeters, which is the width of the photo. The actual width that the photo covers on the steel sample is 0.215 millimeters. Knowing the dimensions, we can solve for the magnification. This solves part 1.
Since we have the magnification, we can determine the grain size number. This equation will determine the number of grains in the given sample. A whole grain has a closed visible boundary. A partial grain is normally found on the outer edges where the grain was cut off. Now that we know the difference, let's count the whole and partial grains and insert the values into the equation. Since we know the number of grains, we can continue solving for the grain size number. We start off by solving for the true area, where W is the print width, H is the print height, and M is the magnification we solved for in number 1.
Now we have the true area that the photo covers and the number of grains in that area. ASTM relates the grain size number, little n, to the number of grains in 1 square inch area of a specimen photo at 100 magnification. This example uses a photo magnification of 768, so some conversions are required. We found that there are 140 grains in 0.0351 square millimeters. ASTM wants number of grains in 1 square inch area of a specimen photo at 100 magnification. So 1 inch on a 100 magnification photo is actually 0.254 millimeters on the specimen. And 1 square inch on a 100 magnification photo is actually 0.0645 square millimeters. Therefore, the actual area per ASTM is equal to 0.0645 square millimeters. We now have an equation with all the variables known and are able to solve for big N. Now that we have a value for big N, we can plug it into the other equation to solve for little n. The grain size number is the little n. In order to bring the unknown little n down from the exponent, we must log both sides. This is our grain size number. We now have completed part 2.
The last thing to do is solve for the average grain size diameter. First, by solving for the total true length, then solving the number of grains intercepted. Number of grains intercepted refers to the grains intercepting two vertical lines. Plug in the values to solve for the average grain diameter. This concludes number 3. We have now solved for all 3 problems.